Okay, next on the agenda is the lunar geology investigation. Dr. Mulberger has the floor. This, of course, has been quite extensive, and the crew has been working along with the preliminary evaluation team over the holidays and up to now in looking at the material, and so we're going to keep it quite general in our discussion today. Bill?
Yes, sir. Now that we've all relieved and vacated our minds, we can start thinking science again. I'd like to point out that we have a complete set of the photographs.
Hey, you know, that reminds me.
And you can walk out to the trailers and take a look at them if we're not currently looking at them ourselves. We have a set of transparencies of the color magazines and 2X black and white prints of all of the black and white magazines. And most of your experiments are in those pictures somewhere, and they're in little folders so that you can locate your own beast. There's about 2,389 pictures, which is a new world's record.
Well, you don't have to look so nasty.
We don't have to look at all of them. SEP we don't need to worry about.
What do you mean there's samples? There are 4 samples around the set. You got to find them.
As you are aware, the traverses went almost nominally, and therefore there's a wealth of data returned geologically, and I want to put our thanks into you guys for doing your usual expected outstanding job. I'd also like to congratulate Captain Lovell on his new assignment. And I think we also should thank him for being such an arbitrator for so many months in SWEP and also in the back room when there were times when I leaped rather violently upon him as well as some others. In spite of that, he really performed admirably most of the time.
Admirably for a captain, anyway.
I think most of you have copies of the report that we produced by Splashdown, which represented our stage of knowledge at that time. It's the most nearly, quote, scientific, unquote, report that we've been able to produce by that moment, primarily because of the accurate descriptions of the materials that were being collected and observed. We've already spent a week or so with the crew and the tapes and listening to their comments again and asking questions on debriefing kinds of things. And the units that were mapped there in the pre-mission seems to hold pretty well. There are still some questions as to how do we interpret some of the dark mantle and subfloor relationships. And the massifs are still there, and the scarp was still there, and bright mantle was still there. So I suspect that in those kinds of details you can see our report as our level of ignorance at that time. One thing we didn't get to do, and I would like to ask you guys some questions concerning, are between the stations and any traverse observations that could have come in, at least in a general way now, because we don't obviously need to do this kind of thing with the photographs in detail and can't fill too much. But initially, when you're in the Lem Alsep area, you started talking about mantling, and would you want to add in any comments post as to, as a result of the traverses, how continuous was mantling, i.e. were all of the rocks filleted, or this kind of, except around the obvious very young fresh craters, which you did comment on in real time?
Bill, my impression was that filleting was there. There was a little bit of a ramp up to the edge of most of the larger rocks, but it wasn't a major feature of the rock. Only where there seemed to be the rock, this would say with a vertical face of the rock, just a very slight ramp up to the rock. But where you got a sloping face, say less than 30 or 40 degrees, then that fillet tended to climb up the side of the rock. So that contact was a gradational one. But for the most part, there weren't many of those slopes like that. There were some flat, low slopes of the block. The blocks generally were angular and blocky and had fairly steep faces at the contact with the mantle. But where however, let me also add that where you had a flat surface that was only a few centimeters above the ground, it tended to be relatively clean. Only the little depressions on that surface and cracks and stuff had obvious fragmental debris in it. Is that about your impression?
Yeah, I don't know. I guess I'd always been a little bit more impressed with the draping, as I call it, of the general mantling over the entire area than Jack was. My
Now wait a
impression.
minute, I'm talking about individual blocks.
Well, I am too, but I'm talking about them on a gross valley-wide scale. I think from the standpoint of filleting, unless, like Jack says, unless it was particularly a downslope, you could see definite buildup of filleting and direction to it. I think on a valley floor there was, I could not, even what I call filleting, I probably could not put a directional attitude on it.
No directional things anywhere on the floor. But, of course, on the
But I
hillside,
got an impression that the
What?
whole area, that whole floor, had been, call it dusted, call it draped, except the obvious places we've pointed out. And to some degree or other, depending upon the size of the rock or boulder that was exposed, that everything was somewhat draped, mantled, dusted over to some degree throughout the whole valley floor. That was the impression that stuck with me and still sticks with me. There are very few, if any, places that I can remember, except around a couple of those craters we talked about, where you get a feeling that any of the fragments that were on the surface were literally on the surface and not being somewhat submerged within that surface. Now, I don't think Jack feels quite as strong about it as
Well,
I
we're
do.
talking about different scales, and I agree with you. If you talk about a crater scale, the craters, I think we commented continually about the appearance that the rims were draped or that the walls were, you had streaks of material that buried portions of the block fields in the wall. But when you come to
Yeah,
an
that-
individual fragment or boulder, most of them were clean, unless they were low to the ground or had a low slope. Then they started to get dirty. But I think most of the fragments are clean. That doesn't mean that they didn't look as if they had an inter-crater cover between, inner block cover between them.
But if
I
I-
didn't have the impression the fragments were dirty except at Van Surg.
Well, you're talking about a covering on top
Yeah.
of them. Well, yeah, I might temper what you say and say I wasn't quite that sure as you were because of the tendency. I felt that I would have to walk a long way across that valley floor to go over to an average size rock and pick it off the surface and say it was literally laying on a covering that was on the valley floor.
I agree with that. All I'm saying is that if there ever was anything on the rocks that eventually ended up on the floor that partially buried them, that was gone.
Yeah,
for the most part.
I think probably in the most areas there was not piles of the material in the crevices or convex areas of the rock. I think that's
Yeah,
probably true.
but the feeling of burial of the rocks, of partial burial, was, I agree with Gene completely, and I think we're saying the same thing.
Okay.
Very definitely you had that impression.
And-
the
and
blocks
that-
were projecting out of something.
And that was not local. That was
Yeah.
valley-wide.
And the only place, though, let me add, at Van Surg, I did have the impression that the blocks were dusted. That was the one place, that there was stuff on the blocks. It was hard to see the texture of the rocks. Now, partly because I think it was the kind of rocks we were dealing with. I mean, there were the fine fragmental breccias, looked like soil breccias finally. But there still was this feeling that that they hadn't been completely cleaned off like other blocks in the area had.
My other impression to go along with that, Bill, is that I think most of those rocks that I'm talking about that were generally buried were rounded to sub-rounded rocks, whereas around Van Surg and a couple other unique places, they became dominantly, by comparison, more angular to subangular. Wouldn't you say that was?
Well, but I think the terms are using, they're relative.
That's
In
right.
your mind, when he said rounded, maybe the blocks, say Station 5, are not conglomeratic rounded boulders. They're in the large scale.
Oh.
They're quite
corners
angular.
are all rounded.
But the corners are rounded.
And I think
That's
when you
easy.
get to Station 5, you begin to get more
Yeah, they're
specific.
sharp-
Van
sharp
Surg and Camelot, some of these areas, you begin to get specific I'm just talking about in general
Yeah.
across the valley.
How about dark mantling materials on the massif walls or in the valleys? Was there anything visible to you there? Any blocks or anything to distinguish why
on the massifs
say
or
the
on the-
cleft and a little bit above the scarp on the north massif, there are some very dark areas on the pre-mission photos. I was wondering if there are any observations you guys could
I never saw anything
remember.
but a gradational change from dark to light at the contact with the massifs in the valley.
Because that's the valley
And
floor,
yeah,
right?
and the cleft.
You never
yeah,
did
it
see
looked a
anything
little
you liked.
darker, and we commented about sunlight and stuff like that, but it,
The wrinkle face textured on the
On the sculptured hill.
sculptured hills was due to a obviously darker albedo or darker reflective surface within those the crest of those wrinkles. But on the massifs, I guess basically answer your question, I'd have to say was no. That the change in a albedo, which made it change from a generally light color to sometimes a very bright reflective white in areas. Very intuitively, can't prove it, maybe your 500s will give you a better idea of it, but I get the feeling like it was just ready to bust out with an outcrop. But no evidence of an
The
outcrop
brightest
was
areas
there.
would be
like you took a piece of
potential outcrop.
sandpaper and you sanded the South Massif down, and you started to begin to hit hard spots, and where you hit hard spots, it generally had a lightened up pattern, but you didn't quite expose any outcrop. That's just an intuitive, descriptive feeling of what I think that change in albedo was.
I don't know. So my feeling was that you were dealing with both differences in the topography along the slope that changed light to dark, plus areas that may have had movement on them more recently were lighter colored. But that may go along with Gene's saying, is that they're a little closer to fresh outcrop.
I think you've answered my question then on Station 8, because the pre-mission maps had that still in dark mantling material, and obviously the albedo things were so subtle you wouldn't have spotted it.
The only that change was gradational, and there's one thing that I think is illustrative of that is there is a medium gray layer on the light mantle. Once you get below this, and we did that primarily at 2A, but I think I noticed in the transcript, I'd forgotten all about it, but Gene kicked up light stuff very briefly at Station 2. Station 3, there was a light gray over the marbled material. It seems that there's a layer of variable thickness, let's say 5 to 10 centimeters in the intercrater areas, on the light mantle, and that coloration was gradational right up onto the talus slope there at Station 2. And so that may be the local regolith development through patination and impact glass and this sort of thing, or it may just be related to dusting, other dark mantle dusting over the whole area. I don't know the answer to that, and only the samples, I think, give the answer.
So that upper 5 centimeters is lighter than the marbled material below on the average, or would the upper 5 centimeters average out to mixed marbled? Oh, that's a detail that maybe we should...
No, it was about the same gray as the gray in the marbling. It's a medium gray in contrast, say, to a little darker gray for the dark mantle and a very light gray for the sub-light mantle material.
As you drove to Shorty, you observed it was darker and thus could easily spot it. As you drove away from Shorty toward Victory, you should have been fairly close, if not crossing one of the dark rays out of there. Did you observe that at all?
I never...
You're going sort of up sun, so it'd be bad seeing, but you didn't.
I never noticed a major change or any change in albedo from Shorty towards 5.
You're so close to them, unless you can stand off, like we did one time approaching the light mantle from the Lamb toward Station 2. As we got closer to it, we were on a rise, and we sort of stood off, and we were relatively close to it. And I was surprised we could see the change that close, but we could. Then we drove down into it, and it disappears, basically, I think.
My main
reflective.
main criteria in the light mantle for saying we're in light mantle was the walls of the crater, say, greater than 5 meters in diameter or so, which were distinctly lighter colored than the walls of craters out in the dark mantle.
If I could interject there, it seems to me that the sun angle and the angle between you and the site you're looking at in the sun would be pretty important there.
Oh, listen,
It
the
is.
sun angle at which you
It is.
drive and observe, you can think you're looking at half a dozen different things.
There's no question that you have to temper almost all your albedo observations with looking directly down sun. As soon as you get a slight, any significant cross-sun component, you're starting to get topographic photometric effects that'll
Do you in?
kill you. And unless the contrast is exceedingly high, you can't be sure you're seeing albedo change.
One of our potential targets for 500s, but which there was no time for, was Pigeon Peak. Do you ever remember ever looking at it, either of you, and seeing whether you could identify it?
Yeah,
Remember that white
That was
I did
blotch
one time when
way up, way up sun
I
in
did,
the
and I-
sculptured hills?
I should have said something about it, but as we came over the scarp, back leaving station between 2 and 3, I looked in that direction and never saw it.
Never saw it.
No, I looked for it.
So we think we found it on the surface photos, your pans, but it's dark. If we've located it right, so we've got to. That's why I wanted to get your.
No, I never noticed it. I tried to see
Impression.
some of those over there. But we had bad lighting for that point, I
You
think,
did.
over in
That's
that
true.
part. Looking into the sun and south slope.
I'd like to point out that the only beers I think owed to me for blurred 500s are probably from Schmidt.
Is that right? I'm glad you made that pronouncement here in
What are you
public.
talking about? We're gonna have to look at some of those.
Yeah, that's a pre-flight photo there.
Any questions?
Kai?
I'm very interested in this.
I didn't make the bet.
I made it for you.
I'm very interested in this question of the albedo. Is this a true statement that wherever you are there and you kick the dust, the underlying dust is darker?
That's true out in the dark mantle. Trying to remember, never had a chance.
It's not.
Well,
true at 16.
we crossed our tracks, and I didn't notice that on the light mantle.
Yeah, it's very interesting. Let me back off. We observed Apollo 15 landing site as well as our own from orbit. And pardon? Yeah, and you can't see the limb or anything else, but you can tell exactly where the limb landed because there's a whole area of disturbed soil that gives you a lighter reflection.
All later.
We could pick out the 15 site as well as we could our own in that valley.
But when you're there, the disturbance is darker.
It's a different angle.
Yeah, and it's dark. So I think I think from orbit, somehow or another the disturbance is you must be getting an anomaly from a different scale feature than the detailed disturbance, because the detailed disturbance is distinctly darker. There's no question it's darker when you're looking at a footprint. But when you look at the area from orbit, it's distinctly lighter.
Well, is it possible that the footprint is just put some shadows in that makes it
No,
more
no,
general
sir.
thing?
No, it's the dust. I mean, as soon as you
The
turn
boot
over,
spray
it's
is
the
the-
spray. The spray is also darker. Yeah, I think it's very clearly a darker albedo, and this is known from Apollo 11 that that's a normal thing for these sites.
Yeah, but the fact that it looks bright from orbit and looks dark.
Well, of course, it's 60 miles versus a meter.
But that's not unusual because so many things that you can see from orbit, like just for instance the white mantle, things that you could see from a standoff distance in terms of the light mantle and other things that when you approach them, you lose sight. You just cannot see the difference in albedo. And I'm sure if you approached them under different sun conditions, sun angle conditions, that would even change it for you also. Shorty, you know, we of course there's no question we're at Shorty, and you could tell you were coming into a darker area. But you know, Shorty is so well defined from orbit. Black versus the light mantle it's sitting right in the middle of. But my impression is that I don't think even if I had to go back and do it again, it would be very difficult to put a contact line around black-white contrast on the surface while you're 6 feet from it.
That you might think about what would happen to albedo of a surface if you swept it in a planar omnidirectional way with a decent engine. Maybe the filleting you get will cause, for some reason, a lightening of the surface rather than in the normal way where it's a random kicking.
Now, that would be radial though, and the sun's coming in from one
No,
side.
no, we're talking about when we were viewing these things. I think we were sufficiently high sun angle
I see.
that may be. You got to consider that, but certainly with our sight, we were just about zero phase when we were seeing this, and then 15. But you saw it earlier. Yeah.
Very obvious. You got a light
Well,
area
then
around it.
that's even better evidence of why
and
it's
that's
disturbed. It's from the
disturbed
decent
from
engine.
decent
That's
engine.
right, because you weren't even able to kick that.
You weren't even up.
It shows up that way on the fan sucker too. It shows up in the light spot.
Sure.
Could that just be
It's
compact?
easy to spot the limb of the pipe.
It could be compaction or
Because of the
directional
light
filleting,
smear
radial
there on the
filleting,
limb.
giving you some kind of a optical surface that's different than what you normally would get.
It's good to see the optics of your, the two viewing your windows. When you're on the surface, you're viewing through a rather sharp angle down on the surface. And were you viewing through the same windows when you were?
Surface panorama show it at any sun angle. You can see where they've walked by the,
But it's always darker.
Yeah.
yeah.
But when you're
Well,
in orbit, would you be looking through the same?
Yeah, but the photography picks up the same. Photography picks up the same effect.
Yeah.
The surface photography compared to orbital photography picks up the light.
Different there.
Their observations on the ground, it's possible their windows were different.
Yeah, well, we're
Viewing windows or viewing helmet?
Oh, excuse me, you're talking also about photography on the ground,
Yeah.
is that right?
Mhm.
Yeah, sorry.
the visual and the photographic evidence is consistent.
Yeah.
Okay, I thought I would talk a little bit about the cores here. This is from the drill stem. You can obviously see right away that the absolute bulk densities from the 17 drill stem are in general higher than either the 15 stem, except right down here for this section, and higher than the absolute bulk densities for the 16 drill stem. The plug that you inserted into the top of the stem did not function. I think you sensed that it wouldn't on the surface because it fell in so easily. We found it at the top of the drill stem, and
With the core intact?
there was some disturbance. Now, fortunately, you put the rammer jammer down, so we could take your estimate as well as review the kinescopes and get an estimate of how deep the sample was on the surface and compare that with how we get it back in the lunar receiving lab. We figure from your rammer jammer that it was down about 30 centimeters. And in the LRL, it's down about 15 centimeters. So we assume that all of the disturbance occurred in the top 3 stems during return to Earth, and that the thing moved roughly 15 centimeters. This line here represents...
Didn't you have a break in the core? Wasn't there a space?
Yes. Just looking at the X-radiographs, we can see 8 plus or minus 4 centimeters of void. Right. So we almost can see as much void as would be predicted if the thing moved in sections,
Yeah,
but not
yeah.
quite.
Yeah.
But based on that sort of information,
And where did the break occur? The base of the break? Do you remember below the surface?
there were 2 breaks. One was the top 6 centimeters of the 3rd stem, and there was 2 centimeters at the top of the 2nd stem missing, or a void. Okay, but based on that kind of information, this is the average bulk density, which is quite high for the top 3, and then this dotted line is my estimate of what it was originally, I guess. And we end up with a layer here, this gravelly layer that Don Burnett mentioned, which is a very high density.
Where's the, see depth there, is the first break in your curve. What's the depth? Is that about,
This is
Yeah.
10 centimeters. Okay?
at the limb, the main change in the properties as a function of pushing things into the ground was probably deeper than that. It was whatever 2/3 of a core tube might be, something on that order.
Now, you mentioned that to me, and that's one possibility that this denser coarse layer corresponds to the resistance that you got pushing in that core at the limb. Based on the drilling rates, now this is it's a little bit difficult to do some of these things, but the relative density, that is how tightly the soil is packed together, suggests that the 15 site was the same or maybe slightly denser, relatively speaking, than your site. In other words, your drill rates were a little faster or more or less the same as the 15 site.
Well, but does that take into account the different drill design?
Same core, drill core. The core didn't change at all.
Core didn't change, okay.
Yeah. This was at Station 3. Then, Station 4, Jack mentioned the high densities for the double that was taken there. You can see that the upper half, assuming it is full, 100% full, which is not normally the case for an upper.
But you remember, I couldn't get that plunger to move at all. So I think they're pretty full.
Okay,
That one went all the way down that double core above the soil.
okay. Density of 2 grams per cubic centimeter, average. And then the average for the lower half is 2.35. These are truly extraordinary densities. I plotted them on this kind of a curve to show you the comparison. If we assume the porosity of this core is typical of the porosities that we found in these cores, which is about 42%, and there's no reason to believe that it would be much less than that, or you couldn't have driven it in the first place. You end up with a specific gravity, the density of the individual grains of slightly more than 4. That's extraordinary.
Well, I think your porosity could be lower. Looking at that stuff in the microscope, they're little beads of glass and things, and they might pack pretty well. It's a very, see, it's sorted, it's sized practically. Correct me when I go wrong here, PET, but my impression was that it was a much better sorted soil than a normal regolith, and it may well be packed better.
Well, actually, the less sorted it is, the better it packs.
Well, you're right, the angular fragments.
Yeah. So I think we have a very different material in this double core tube. I suspect that the density is not the orange soil, but the black soil that you found underneath. And very anxious to get into that. One other comment then on the orange soil itself, just a qualitative impression, but besides all the other interesting things about it, it appears to be one of the most cohesive soils that have been returned. Cohesive, sticking together. So
It was that way in the field. Broke into fragments, actually.
Thanks, Dave.
well, I had a quick question.
Yeah, we did.
Yes. Would you verify the exact procedure you used with the CSVC then?
I use the exact procedure as we plan to use, as trained for, and what.
I understand. Go ahead and repeat that, would you? Just to be sure.
No, I won't. I won't repeat it. I did it as planned. I don't. Do you have a specific question as to what you doubt on it or something?
Well,
Where's the doubt?
I received what you did second and third hand, so I would like to just verify exactly what.
Yeah, I'm going to have to review and think back about it, and I just did it as we had trained and planned. Bob Parker will tell you what I did. That's about as first-hand as you can get. But it went in
The
it.
thing I'm after is that you push the keeper out of the adapter, right? And then drop the keeper.
Yeah, that's in the transcript.
Well, it was a full core, and the keeper, I pushed it out and I let it lay on top of the core and threw the top away, and then put it in and sealed it. So the keeper was on there, but as I recall, the keeper, core was so full that the keeper, you couldn't compress it, and the keeper was not wedged within the circumference of the tube. It was just laying on top when it went into the can. And then I dumped it a little out and I put our patch in there just so you know who collected it.
Visually, it was well graded, just like on the
Which fine grain material? All of it?
in general.
In general, my impression was that the dark mantle materials were sorted, that they were biased into the fine grain fraction, at least the surface stuff, that you did not see much granule and greater size materials until you got up to the fragment population, which were scattered around up to big blocks. That's just an impression. I don't know how that's going to turn out, but I expected to see more of what it would visually appear to be a serrate fragment population. It is an exponential increase of fragments as you get smaller, but it seemed to me more biased towards the smaller size range. And the same, however, in the light mantle, although very fine grain, you tended, purely impression that it seemed to be more of a serrate population of fragments. You saw little grains, little fragments in that, whereas I almost never saw them, except on tops of rocks. Like the one we took there, Station 5, you could see little fragments of rock in the sample we took. And I suspect those did come off the rock there, granulated rock rather than the dark mantle. Well, that's what I'm saying. In a serrate population, what was missing, I think, was the granule to 1 centimeter size, let's say, because I just didn't notice that.